This simulation uses voiceovers. Using the lab pad is an important way to get the most out of this simulation. It's perfect, then let's get started. Before we can begin our investigation into alcohol flush syndrome, you will need to learn how to use a spectrophotometer to measure enzyme activity. Don't worry, I'll help you along the way. A spectrophotometer uses light to measure the concentration of a specific substance. In our enzyme kinetics experiment, we will determine product concentration by measuring how much light is absorbed at a specific wavelength. Once we know the enzyme and product concentration, we can then determine the kinetics of that enzyme. The goal of this experiment is to find out how we can measure the activity of the alcohol dehydrogenase enzyme using the spectrophotometer. Alright, let's start with some theory on how a spectrophotometer works. Light with the chosen wavelength is shone on the sample. Some light is absorbed by the sample and some passes through. The amount of light that passes through the sample is referred to as transmitted intensity, and is quantified by a detector. The ratio of light shone on the sample to that which passes through the sample is called the absorbance value. To learn more about how spectrophotometry works, you can click the View Theory button. What is the function of a spectrophotometer? Great job! The amount of light that passes through the cuvette is determined by its contents. The higher the content density, the less light can pass through. This is how we can calculate the concentration inside the cuvette. We want to determine the concentration of NADH in a solution that also contains NAD+. Have a look at the graph. Which wavelength is optimal to measure NADH? You can also click the View Image button to learn more about the graph. That's right. The optimal wavelength is the one that gives the highest specific absorption value. For NADH this is 340 nanometers. At 260 nanometers the absorbance value is even higher, but it is not specific for NADH as both NADH and NAD+ absorb light at 260 nanometers. Hence, it is best to measure NADH at 340 nanometers where the absorption value is high and it is specific only for NADH. Define the absorbance value displayed on the spectrophotometer. Correct. The absorbance value displayed on the spectrophotometer is the measurement of light that is absorbed by the sample. It is calculated as the logarithm of the ratio between light falling on and passing through the sample. An absorbance value of 1 means that 1/10 of the incident light is detected. An absorbance value of 2 means that only 1/100th of light reaches the detector. You will find the spectrophotometry workbench in the right side of the lab. Click on the Put on gloves before you start your. We need to prepare a master mix with the reagents for each reaction. What is included in the master mix? Great job! We need ethanol, NAD+. Why don't we add the enzyme into the master mix? That's correct. Once the enzyme is added, the conversion starts. We need to measure immediately after the enzyme is added. Hence we only mix the enzyme with the master mix in the cuvette and measure right away. Take a new 15 ml tube from the tube box. Prepare the master mix by adding ethanol into the 15 ml tube by using the pipette. That's correct. Ethanol is the substrate that will bind to the active site and be converted into a product. Add the second liquid for the master mix. Add NAD+ into the same 15 ml tube. What is the function of NAD+? That's correct. Some enzymes need a cofactor that will also bind to the active site in order to convert the substrate into a product. Alcohol dehydrogenase or ADH is a bisubstrate enzyme, meaning that the enzyme has two substrates. As well as being a cofactor, NAD+ is also acting as the second substrate. Add the final liquid for the master mix. Add buffer into the same 15 ml tube. Why do we need to add buffer into the master mix? That's correct. The buffer keeps the pH stable even with the addition of small amounts of acids or bases. Place the pipette back in its rack and take a new cuvette from the cuvette box. Place the new cuvette in the cuvette. Before we measure a sample, we need to set the absorbance baseline with a reference blank. The spectrophotometer measures the absorbance of the reference solution and sets this as 0. This gives a stable baseline to measure from, ensuring any measured absorbance relates only to the reaction's product being formed in solution. The assistant has made up your blank and placed it in the cuvette rack. Now you need to set the measurement baseline before we start measuring enzyme activity. Set the baseline using the reference cuvette in the rack. Click on the lab pad for more info. Click Start to begin the baseline measurement. Add the master mix and the ADH1B*1 enzyme into the new cuvette in the cuvette rack using the pipette. The master mix now contains 0.16 ml of 10 micromole ethanol, 0.2 ml of 10 micromole NAD+, and 0.54 ml buffer. We will add 0.1 ml of 1 mg divided by milliliter ADH so that the total volume will be 1 ml. What is the substrate concentration in this master mix? Good job. You can use the dilution formula C1V1 equals C2V2 where C is the concentration. Add the master mix and the ADH1B*1 enzyme into the new cuvette in the cuvette rack using the pipette. Enzymes are biological catalysts. What aspect of a reaction do they lower, thereby increasing the reaction rate dramatically? That's correct. By lowering the activation energy, enzymes accelerate the reaction rate by up to 1,000,000 times fast. Take the reference blank out and place the cuvette that contains our sample and insert it into the spectrophotometer. Close the spectrophotometer and click Start to begin the measurement. This is the enzyme alcohol dehydrogenase with its substrates and cofactor. NAD+ is a cofactor that is needed for the reaction to take place. What is the function of cofactor NAD+? That's correct. NAD+ receives a hydrogen ion and 2 electrons from ethanol, converting it to acetaldehyde. Ethanol is the main substrate for the enzyme alcohol dehydrogenase. Besides the ethanol and NAD+, zinc ions are also needed for the reaction to proceed. The reaction will take place at the enzyme's active site, which consists of several amino acids. One important amino acid is arginine at position 47. The zinc ion is located close to the water molecule. The NAD+ and ethanol bind with the side chain on arg 47. What was just shown in the animation? Good job. The substrate ethanol is now bound to the enzyme's active site, creating an enzyme-substrate complex. When the reaction produces no intermediates, which of the following rate constant will be equal to kcat? That's right. If the reaction path proceeds over one or several intermediates, kcat will be a function of several elementary rate constants. There are no intermediates in this reaction, therefore, kcat will be equal to K2. Kcat is also called the turnover number and denotes the maximal number of enzymatic reactions catalyzed per second. One hydride ion is transferred to NAD+, forming NADH, and one is released freely. Acetaldehyde is then produced. For every single reaction, one ethanol is converted into one acetaldehyde and one NAD+ is converted into one NADH. Click on the computer screen to see the NADH absorbance. Wait until the chart is finished. You are given ethanol with a stock concentration of 50 micromole. Calculate the ethanol volume for two master mixes with final substrate concentrations of 0 millimole and 0.0053 millimole in a final volume of 1 milliliter. Good job! You can use the dilution formula M1 multiplied by V1 equals M2 multiplied by V2, where M is the concentration and V is the volume, to calculate how much volume is needed to create a final concentration given. We used a simulator for this experiment. In reality, you would have to prepare one cuvette for each enzyme and substrate concentration and measure each in succession. Measuring multiple reactions this way takes a long time, but in Labster's virtual laboratory, we can speed up time so each reaction takes only a couple of seconds. Furthermore, most spectrophotometers can measure absorbance values of between 0.2 and 1. But in this virtual lab, our sensitive spectrophotometer can accurately measure lower absorbance values. Click on the computer to alter the parameters. Use the slider to change the enzyme or substrate concentration. Change the substrate and enzyme concentration parameters and plot the graph. Which part of the curve should you use to measure the initial reaction rate? That's correct. The initial reaction rate is measured during the linear part of the enzyme reactions shortly after the conversion started. The V0 will be calculated for you and the result shown on the simulator. Click on the computer to change the substrate and enzyme concentration and plot the graph. Find the ideal enzyme concentration that consumes 16 micromole ethanol within 130 seconds. Raise the lab pad if you need guidance. Have you found the optimal enzyme concentration? Find the ideal enzyme concentration that consumes 16 micromole ethanol within 130 seconds. Raise the lab pad if you need guidance. Have you found the optimal enzyme concentration? Correct. It is important to use an optimal enzyme concentration so that you can measure your experiment accurately and in a timely manner. Alright. As you can see, when you increase the substrate or decrease the enzyme concentration, the reaction takes a longer time to complete. Conversely, when you decrease the substrate or increase the enzyme concentration, the reaction takes less time to complete. However, if you use too much substrate or enzyme, the reaction becomes too fast and we cannot accurately measure the product formation. When designing an enzyme kinetics experiment, one must balance the substrate and enzyme concentration so that the reaction is not too fast nor too slow. Raise the lab pad when you are ready. Would you like to stay and play with the simulator to see the results? Use the sliders on the computer screen to alter the pH and temperature. The computer will run a simulation using the optimized substrate and enzyme concentration and the chosen pH and temperature. It will then plot the progress curve based on the determined condition. Are you able to determine the optimal pH and temperature for the ADH enzyme? Click on the computer to change the pH and temperature. Continue to experiment with different values or click here to continue. Did you determine the optimal pH and temperature? What is the optimal pH for the alcohol dehydrogenase enzyme? Correct. The pH can affect the ionization state of amino acids. A change in pH can alter the ionic bonds, determining the 3D shape of the enzymes, resulting in altered protein recognition or even inactivating the enzyme. Changing the pH can also change the shape or charge properties of the substrate, causing it not to bind to the active site or stop catalysis. Each enzyme has a specific optimal pH where it has the highest activity. What is the optimal temperature for the alcohol dehydrogenase enzyme? Correct. As the temperature rises, reacting molecules have more kinetic energy, resulting in increased chances of a successful collision. There is a certain temperature where an enzyme's catalytic activity is at its greatest. Above this temperature, the enzyme structure begins to break down. At high Great effort. You've determined that the optimal pH and temperature for the ADH. Raise the lab pad when you are ready to continue to the next mission. Would you like to stay and play with the simulator? Good morning, doctor. I have some questions about the patient.
He hit his head when he fell down last night. His friend brought him in from the student bar. The friend said that he just had one beer when he lost his balance and fell down. But when he came here, he looked a lot like an intoxicated person who had drunk a large amount of alcohol.
Is there anything else you'd like to know?
Well, I have seen something like this before. Some people seem to have a lower tolerance level for alcohol. Even with little alcohol consumption, they become intoxicated. Their heart starts beating rapidly, their skin flushes, similar to how others react after consuming large amounts of alcohol. This condition is known as alcohol flush syndrome.
Is there anything else you'd like to know?
Alcohol is a toxic substance and our body will convert it into something less toxic and subsequently excrete it. First, alcohol is converted into acetaldehyde by ADH based on the following reaction. But acetaldehyde is actually more toxic than alcohol. It is rapidly converted into acetic acid by the ALDH enzyme. Acetaldehyde is the substance responsible for the intoxicated feeling.
Is there anything else you'd like to know?
Upon consumption, alcohol passes from the stomach and intestine into the bloodstream, which leads to the liver. In the liver, alcohol is metabolized by enzymes such as ADH.
Is there anything else you'd like to know? Okay, let's investigate this patient's ADH enzyme. Now that you are an expert of enzyme kinetics, you can perform the experiment and check if their ADH enzyme might have contributed to their circumstances. The lab assistant has isolated and prepared both wild-type ADH and mutant ADH enzymes for you. We first need to compare the function of these variant proteins so we will know if the patient's version functions like the wild-type or mutant. The concentration of both enzymes is the same, 0.1 mg per milliliter. Use the simulator to change the substrate concentration and find out the Km and Vmax value. Remember that the simulator tells you the absorbance at 340 nanometers resulting from the enzyme's product formed. Head over to the computer to use the simulator. Go to the spectrophotometry workbench. Click on the computer screen. Choose the type of enzyme and ethanol concentration before clicking plot. The y-axis of the progress curve shows the absorbance value. How can we convert this into product concentration? Yes, that's correct. By using the Beer-Lambert law, you can convert the absorbance value to product concentration with known molar extinction coefficient and path length. In this case, the molar extinction coefficient of NADH is 6220 m1 and the path length. Great job! What values do we need to calculate first, before we can plot the Michaelis-Menten curve? That's right. We need to first calculate the initial reaction rate, which continue to experiment with different values or click here to continue. Would you like to continue directly to the data analysis? What is the estimated Vmax for wild-type ADH? Good job! Vmax is the upper limit for the value VO. The value of Vmax can be estimated by looking at the Michaelis-Menten graph. The exact value of Vmax can be calculated from the linear regression Lineweaver-Burke graph. The formula of the linear regression is so the Vmax equals 1 divided by 0.0556 equals 17.98 micromole per minute. And what is the estimated Vmax for mutant ADH? Good job. As you can see, the Vmax for mutant ADH is a lot higher than for the wild-type ADH. Vmax is the maximal initial rate. Looking at the plot, which one is Km? That's correct. Km is the substrate concentration when the reaction rate is half of its theoretical maximum. Now, let's have a look at your Michaelis-Menten plot again. What is the Km for wild-type ADH? Good job. Km is the substrate concentration that corresponds to 1 divided by 2 of the Vmax. From the Michaelis-Menten graph, the K, and what would the Km be for the mutant ADH? Great job. As you can see, the Km for mutant ADH is also higher than the Km for the wild-type ADH. A high Km means a lot of substrate must be present to saturate the enzyme, meaning the enzyme has low affinity for the substrate. What could explain the difference observed in the two enzymes? That's correct. A DNA mutation can alter an enzyme's activity, resulting in altered enzyme activity. In this case, it was a When analyzing inhibition kinetics, which plot would you use to determine the inhibition type? Good job. Lineweaver-Burke is also referred to as a double reciprocal plot. Go to the spectrophotometry workbench and click on one of the 3 15 ml tubes to see. Let's perform the enzyme kinetics for one inhibitor first, using all 4 concentrations, and analyze the data before continuing to the other inhibitors. Would you like to stay and play with the simulator to see the result? What kind of inhibitor is hydroxylamine? Great work. Hydroxylamine is indeed a competitive inhibitor for the enzyme alcohol dehydrogenase. What happens to the values of Vmax and Km in the presence of a competitive inhibitor, respectively? That's not quite right. Please try again and remember you can check out the theory pages if you need more information. Fantastic! As you can see from the resulting velocity curve, when the hydroxylamine concentration was increased, the Vmax remained the same. It only took a long time. What is the approximate Vmax value for the hydroxylamine inhibition? Great job! In competitive inhibition, how can you calculate the Ki for a competitive inhibition? That's right. The change in Km (ap) for competitive inhibition reflects a decrease in the enzyme's affinity for the substrate because the inhibitor competes with the substrate for the binding site. By plotting the slope of different Lineweaver-Burke plots at different inhibitor concentrations against the inhibitor concentration, you can find I by using linear regression, since the following equation describes this slope. What is the approximate Ki value for hydroxylamine? Super! The Ki value can be determined by plotting the Km over the inhibitor concentration. This plot should therefore also result in a straight line with the intersect Km divided by Vmax, and slope Km divided by V. Let's perform the enzyme kinetics for one inhibitor first, using all four concentrations, and analyze the data before continuing to the other inhibitors. Would you like to stay and play with the simulator to see the result of changing a What kind of inhibitor is cimetidine? Great work! Cimetidine is indeed a non-competitive inhibitor for the enzyme alcohol dehydrogenase. A non-competitive What happens to the values of Vmax and Km in the presence of a non-competitive inhibitor, respectively? That's not quite right. Please try again and remember you can check out the theory pages if you need. The lower the Vmax value is, what is the approximate Ki value for the cimetidine inhibition? Super! You can calculate the Ki value by plotting 1 divided by Vmax over inhibitor. Let's perform the enzyme kinetics for one inhibitor first, using all 4 concentrations and analyze the data before. Would you like to stay and play with the sim? What kind of inhibitor is formamide? Great work! What happens to the values of Vmax and Km in the presence of a incompetitive inhibitor, respectively? Fantastic! As you can see from the result, what is the approximate Km value for the 100 micromole for? Great job! As you can see, when the inhibitor concentration is around the key, what is the approximate key value for the formamide inhibition? Yes, you got it. Ki for an There are no drugs currently registered for treating alcohol flush syndrome. It might not be that bad after all to be hypersensitive to ethanol. You can save a lot of money and improve your health by not binge drinking every weekend. Too much alcohol can cause liver scarring. Research has shown that people experiencing alcohol flush syndrome are less likely to develop alcoholism, probably because drinking is so unpleasant for them. Let me ask you one last question. Thank you for your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.